In the back, Amy Phipps. She is sales at Ally, and then Todd Gears is the owner here at Ally. Thank you guys all for coming. I know it's hard. I was in manufacturing for several years, and I know it's hard to get away from the office or from the shop. So thank you guys for coming. We took on the iMachining solution just because, number one, we thought it was going to be very beneficial for our customers. And then when we started talking to the iMachining guys, I'll let them introduce themselves here in a minute, but we realized that their company aligns very well with our company. They're very service oriented, so they're not just going to sell you a product and here, good luck. They're very service oriented, and that's what we try to be for our customers. So technical support, again, just being there for your customers. So that's one of the other reasons that we kind of are teaming up with iMachining for NX. So I will turn it over to Steve, and then we're also recording this through GoToMeeting. So if you guys want to get the recording afterwards, I'll get you a link where you can download the recording and share it with other people at your facility. So again, thank you guys for being here. I appreciate it.
Perfect, Chad. Thank you. I'll echo what Chad said. Thank you, everyone. We know it's a little bit of time out of your day, and we hope to make this as valuable as possible for you. So, my name is Steve Welch. I'm an account manager here at iMachining for NX. The brains of the outfit is going to be Greg Abbas, senior application engineer for us. I think you'll really appreciate the fact that he also knows NX CAM inside and out. So comes with practical, real-world experience, and we'll be able to point out, where iMachining for NX can fit for you. So also want to thank the Ally PLM folks. It's a relatively new partnership. I will say this, again, kind of going back to what Chad said, everyone we've met really is customer focused, and that's the same thing for us as well. It's not just software you're selling, you're really selling productivity. And to a person at Ally, great company as far as Greg and I can tell, and we're looking forward to a really strong partnership. So kind of a quick agenda. What we're going to do is I'd like to run through just a little bit of a history of iMachining for NX. Won't try to bore you to death with PowerPoint. We'll get through this as quickly as possible. But we would like to cover some of the technical differences between us and some of the other solutions out there as well. And then Greg is going to hop into showing you the actual software. So one thing I want to stress too, questions that come up, we'd like to address them on the fly. So if anything comes to mind or you want some more detail on anything, definitely just, let's try to address them for you on the fly. So as far as the overview, we'll touch on how iMachining became a Siemens partner. We're going to talk about some of the technology differences between us and everybody else. We have one video at the end, and then Greg will hop into the software itself. So open Q&A at the end. Siemens became aware of iMachining back at the EMO trade show in Germany in, what was it, Greg, 2013? Yep. Really were intrigued by what they saw and we kind of approached each other, I think, and started development on the software. iMachining's been on the market. It's not new technology, 4 or 5 years, so you're not looking at, kind of being a guinea pig. It's proven technology working around the globe. The integration to NX itself has just kind of become, our focus. So, a little bit of what it can do for our customers. Much faster cycle times. We're managing the tool's engagement in the material at all times, guys. So we're seeing tool life increases of anywhere from 2 to 10 times over traditional methods. Really performs well in the hard materials. Inconel's, titaniums, the harder the material, the better iMachining is working. We're going to show you why. The ability to use smaller, less expensive tools too, because we're managing that engagement in the material at all times. We're finding that customers can use smaller, less expensive tools and actually get better productivity. So, if people are familiar with NX, We feel like with the iMachining technology wizard and already having a background with NX, should be easy to, really learn the software and become productive with. So, there's a couple statements. Again, the software is a new technology, proven out there. Some of the things some of our current users have said about the product. We've been getting rave reviews for a long time. Just touching on some of the technological differences between traditional milling and iMachining. Some of these slides might look or some of these scenarios might look familiar. Typical milling or machining, you're running a tool into 180-degree engagement, and that's tough on the machine, it's tough on the tool. You have to slow things down in order to accommodate for those, those corners. So typically, if you're not working on a model, a lot of air cutting, and also irregular tool paths. So you're typically using constant tool step overs. So some of the things that iMachining is going to do, I'll throw this over to you, Greg, if you wouldn't mind.
So what we do is we maintain controlled step overs. We're looking for a minimum and maximum market engagement, and we maintain those. And as we're doing that, we're also adjusting feed rates as well. So if your engagement goes down, your feed rates go up to maintain a consistent chip load. As we're machining, we're constantly updating the in-process work piece. So we're aware of where we've cut, and we know where we need to go. And we're always trying to do intelligent transitions from cut area to cut area. Sometimes we determine that we're not going to retract completely out of the part and move over. We'll slightly move down or slightly move up a couple thousandths and transition to the other side of a pocket at a fast speed. We don't typically rapid when we do that. We give the customers the ability to rapid. The majority of the time, we control like a 500, 600, or 1,000 or 1,000 inches per minute feed rate over to the other position. And we can transition around the part and do a contoured transition to another area. Smooth tangent tool path, so we're always trying to roll in and roll out of the material. So if you're getting a thin chip as you're going into the cut, and you're getting a thin chip as you're coming out of the cut, to make those transitions easier. Which,
can you speak up just a little bit?
Sure. Sure.
Recording.
Some of our patented features in iMachining. One thing we do that nobody else is able to do is a spiral morph, which is the most efficient way to remove material from a specific area. And we do that by maintaining a minimum and maximum market engagement. And working from the center out, we start at a spiral, and as we transition out, we try to create the shape of the boundary that we're cutting. Another thing that we do is separation. So we look at a specific area and determine, would it be more efficient to do a spiral morph for this whole area, or would we separate it out into individual channels and then create 3 independent spiral morphed areas? So we do time calculation with both results, and we pick whichever one's faster. This kind of shows what a finished channeled and then spiral morphed area would look like.
Some people in the room might be familiar with the term tricoidal, and we get compared with that a lot.
Yeah, we don't do a traditional tricoidal. We do what is D-shaped contouring when we do a slot. So we transition, engage into the material, make a cut, transition out, move slightly up, and fast feed across. So you're not doing a consistent feed rate and doing large circles. Another thing that we do when we're looking at cutting tools, and you provide us with information on helix angle, the type of material, one thing that we're looking at specifically is the helix angle, and we try to maintain what we call ACPs, which is an actual axial contact point along the flute. We try to maintain a minimum of 3 contact points based on your depth of cut to add stability to the process. So you're not getting an interrupted flute coming in and out out of the cut without another flute being in contact at the same time. This is an example of rest machining in specific material or specific areas. You can see that we tried to do as little motion as possible. We transition down in the part. We're not retracting up unless we have to.
It's kind of interesting because the genesis of the technology, everyone, was for corner picking. And the developers at our company started figuring out, boy, that's an efficient tool path. How can we apply that to cutting an entire part? Went to work on that, and it's really been a nice solution.
Another thing we do that nobody else is currently doing is what we call scallop height tolerances. So when we manufacture a pocket, we'll go full depth, and then we'll do a scallop height calculation. If you're on a contoured surface or an angled 5-axis wall, we'll come back after we went full depth and move up those features and create a scalloped area. So you're not having to create a semi-finished path to come back in and clean those areas up to go into a finished operation.
This is really kind of what we're utilizing with the iMachining technology. And in a nutshell, we're taking into account the machine, the material being cut, the geometry of the part, and the tool that you're using, and giving you what we call a machining level. Greg's going to talk about this in the software, so I won't beat it to death right now. But it's really like putting a skilled machinist at your fingertips. And for anyone in the room that is a highly skilled machinist, I feel like it really gets you to most efficiency on that first part versus having to guess or kind of slow things down to make sure you get it and then ramp that up. So we'll talk about this in a little bit more detail. It really can help improve efficiency all around. Again, there's 4 things that we're managing. Material, Craig, if you would. These are the things we look at in regards to the material itself. Hardness is one of the keys. As far as the tools that you're using, those are what we're monitoring. And it's situational per the part and per the job. So we're analyzing that each time you're having to program a part. The geometry itself, we're looking at the maximum depth going down as far as we can every time. And then the machine, we're looking at the maximum power of the machine, the maximum spindle speed, and the maximum feed rate. So we're doing all the hard work in the background based on these parameters. Again, not to run any of my competitors down, but what we're seeing is they're doing full engagement, full depth cutting, but there's still a lot of manual data that has to be entered. I've seen one where you have kind of a spreadsheet. Machine could be this and material could be this, and you're having to kind of figure out. We're doing that all automatically for our customers.
One thing I'd like to touch on is the max power. So one reason we do max power is if you do a lot of aluminum machining, we have the ability to base feeds and speeds and depth of cut based on utilizing as much horsepower as possible. So we'll increase feed rates, increase depths of cuts, and based off the type of material, we will determine how to get it to the maximum horsepower. Yes?
Under tool, you list hardness, so are you asking for different grades of carbide?
Right now, we ask for we've got a few options. You've got high-speed steel, you have cobalt, you have standard carbide, and you have a premium carbide.
Good question. Do you kind of struggle with that a little bit, or just kind of curious?
I run tools at minus 321 degrees Fahrenheit. So yes, we play with grades of carbide a lot.
Okay, beautiful.
And your premium grades would be like your Sandvik H10Fs, H12Fs, things like that, ceratizits.
Just one quick thing to touch on the tools too. There's a common misconception a lot of times, or sometimes people think, right, technology is great, but I'm going to have to buy super high-end expensive tools. And what we're finding with iMachining is that you can, again, buy smaller, less expensive tools because we're managing the engagement and the material at all times. Those less expensive tools are actually lasting longer because you're never running them into that 180-degree engagement. So, and again, the harder the material, the better iMachining performs. So, just a quick slide of some of the industries that we work in and some of the customers that have put their faith in our product. Also very tight with some of the bigger tool manufacturers that really take into the technology and wanted to partner with us. So, quick video, we'd like to show you just a gentleman with iMachining in action, and ladies.
I'll make you present.
Any questions about the technology before we kind of hop into the video? Everybody still odd? I got an eraser up here.
What is this one? 3D mode. Yeah, you can show that. You get your phone camera.
Short video and then we'll
So this is a good example of scallop and how we maintain it. You'll see how we're trying to pull that at first, spiral morphing in, creating final shape, doing the final taking the corners. So as you can see, when we're transitioning back into the other corner, that's not at a standard feed rate. We're just doing a fast feed to get back there instead of doing the traditional coming back up, going over the part, coming back down and wasting time.
Did you just throw an air on the tool there, or is that an empty weapon?
I believe that's just an air blast.
Yeah, the interesting piece is a lot of the heat is going out with the chip. So certain materials, not all, but air actually works better.
We find cutting, steel, stainless, things like that, cutting and drying with this technology does really lend itself to be a better solution. Exactly. You're not shocking the tool.
You can see right here is a good example of that transition. Different angles, all these points are identical, so it really helps speed up the finishing to do better finish faster. Less stress on the tool and the machine.
And it's not on a level base. So if we have a feature, as you can see here, we have a feature that is not as steep of an enclosure, we do less cuts there. The area that's more steep, we'll add extra passes in there to maintain that scallop height.
One of the other common misconceptions that we seem to run across is, okay, great, I like the technology. Now you're going to force me to buy a $500,000, $25,000 spindle machine to get the result. And that's actually false. What we're finding is even older CNC machines, what we're doing is because we're managing all those parameters, we're maximizing any machine, no matter what the age and capabilities, we're maximizing that machine's capabilities. So we have had instances of people looking at having to add a machine. They got better productivity with iMachining and could put off, adding another CNC. So that situation a little bit. That is kind of it, I believe, Greg, for the PowerPoint, correct?
That's the last slide right there.
Any questions? Yeah. If there are any questions, we'll take those now. Otherwise, let's hop into the software. Anyone? All right, let's do it. I don't know if it's better. Can you guys in the back tell me? Yeah, oops, not this one. Which one was it, Chad?
Yeah, the one on the left.
Yeah. Yeah, we lit. There you go. Is that good for everybody still? Nobody wants to work in my face. Another back.
also, I forgot to mention everything that's in front of you. We had laid out the mouse pad, the iMachining information. You have my card, and then our brochures. Those are free to take with you.
All right, so to start off showing the software, I'll go over a few things initially. First being the two type of operations that we provide and where they're located. So typically, as in NX, you're going to go find iMachining and the drop-down, and we provide a 3D toolpath as well as a 2D toolpath. 3D works very similar to cavity mill, but with our technology. Geometry selection, you're selecting a part, model, a stock model, check geometry, things like that. 2D, you're selecting a boundary, just like you would in planer mill. So we'll start off going through an operation. I've already got some tools built. Unless anybody like me to go through building a tool or anything, showing that part of it. Okay. Select the workpiece. So this is the interface for iMachining for the 2D side of it. We'll start off by going through some of the settings and how they work. We're looking for a few things. So we look for what machine you're currently wanting to work on. I've got a few options there. And the type of material. And we've got a pretty extensive library that comes in the install of alloy steels, carbon steels, tool steels. So we'll select aluminum for now. And then we also look for something called a machining risk. So what this does is gives you the ability to say, is my setup secure? Am I working in a vise low on the table, or am I working up in the air? And I'm kind of concerned that we're going to get vibrations. You've got the ability to adjust parameters based on your setup. And then we have a database that you can go in and add machines to if you wanted to. And what we're looking for, like we said in the presentation, is maximum spindle speed, what's the maximum feed rate of the machine, and then we use that maximum feed rate typically for our transition moves instead of rapids. We also look for the spindle horsepower, and then the default machining level. And I'll touch base on what the machining level is in a second. And the ACP is how sound is the spindle, more or less, is what we're looking for there. And the steels, so if you go to create in the material database, if you go there to create a new material, so we'll just create a test material. What we're looking for specifically is the ultimate tensile strength. You can go to MetLab online and get this for most materials that are out there. And then the machinability factor of that material. And then you have the ability to hard code some limits if you would like, or you can allow the system to do it automatically. So with that, we also have some technologies inside of 2D iMachining, iFinish, iRust, iRough. iRough is traditional roughing toolpath. iFinish is after you've created a roughing path. If you want to turn that into a finish, you just copy it, bring it down to the next level, and turn it to iFinish, regenerate, and then it creates the finish path for you. iRust, we can do one of two things. We can look at a previous tool, or we can select a previous iMachining operation to grab the updated stock from. So geometry selection is a little bit different. It is internal to the interface. So we'll just come in here and we'll select these 3 cylinders. And then from there, you've got the ability to do 3+2 if you want to do it on an angle to the part. If you're doing 5-axis work, we'll leave it at standard tool axis. And we're also setting cutting levels in this operation. So we're looking for the clearance level, the upper level, and the depth. You can use model features to select this. Cutting parameters. There is some features in here to control specific things. You can control the step downs if you're not using the wizard. Wall offset, island offset, floor offset. You get the ability, so I showed you in the demonstration or in the PowerPoint channeling. So you've got the ability to modify those channels as well. You can say I want the channel to be 1 inch instead of 3/4 of an inch wide. You can also do what we look for as a thin wall. So if you're coming up to an island or another thin wall and you don't want that wall to get below a specific thickness, we've also got the ability to control that as well. Arc fitting, if you've got older equipment, we can, instead of linearizing all the motion, we can kind of do a poor man's nerve, if you will. We'll take those generated points and create an arc to best fit. So from here, here's where your tool selection is. Like I said earlier, you've got carbide, cobalt, high-speed steel, and premium carbide. And then we're also looking for the helix angle of the tool to find out what the actual contact points are. And this is kind of a wizard, as you saw earlier. And we're looking for a few things here. Machining level is basically how aggressive do you want to be. 1 being the lightest cut, 8 being the largest cut. And as you can see, the step overs change based on what level you're at. You can also look at what your angle of engagement would be with those parameters. And we also give you the ability to lock those down or change them or do what you want. So for me, the wizard is kind of a tool to get you to your starting point. And then as you're trying to develop a process, you can use these to further increase productivity. If you want to get a little bit more aggressive on your maximum angle, you want to change your chip thickness from 5 thousandths to 8 thousandths, things like that. We also have what we call turbo mode, and what that does is typically in aluminum, people want to get a little bit more aggressive than what we do with the standard calculations. So when you click turbo mode, it turns the machining level 1 or 8 becomes 1, and then you get another 7 levels above it. So, and from there, we'll generate the toolpath. As you can see, it's a circular hole, so you get a helical entry, and then you get a spiral out. Like I said earlier, if you wanted to create a finish operation, you can copy and paste it, come back in, change it to an iFinish. Select the previous operation so it knows where it was, and generate. So now you've got a finish path. So from here we'll go and we'll do a 3D iMachining operation. Majority of the interface is the same. There are a few extra things that may need to be filled out or used. We're looking for a geometry group with a part and stock in it. Even in the 2D operations, we do require at least having a geometry group built so we can update the stock and pass it to the other iMachining operations. Settings are the same. I don't have to come back in here and reselect everything. We update at the main level. When you create your first operation, it stays in the file. You don't have to push it or do anything. So it maintains all of its settings from the previous selection. So for 3D, we'll do the same thing. We'll select our clearance level, our upper level, and I'll come in and I'll just select a feature on the part. So in the cutting parameters, there are a few things. So we talked about scallop height. You can either do it by scallop or you can do it by constant. Typically, I do it by scallop. You've got the ability to come in here and modify what you want that scallop height to be. If you wanted it to be 5/10 or 5/1000, you can come in and modify it. We'll just make it 150. And we'll generate. Any questions while it's generating? Yeah, you can do an entry hole. You don't have to select an entry point either. We know the hole's there, so we'll use that if we deem that that's the most efficient way to get into the material. So there's the operation. You also have the ability to do a trim boundary. So if you wanted to come in here and say, I wanted to do a working area, come in, select tangent curves, and say, I want to do that pocket there, and recalculate. This part's not big enough to show you. I'm going to open up a larger part and show you some of the processing stuff that's going on in the background as well. So you got the ability to select a specific area if you want to stay inside of it. And if you're curious how it works with Siemens internal operations, you can do a planar mill operation, you can do a 2D operation, you can then do a 3D iMachining, you can flip-flop back in and out of sequential mill. As long as you're updating the stock through a geometry group, we know what's machined and we also use it as well. Verification works the same. So if you want to do a 3D verify, you can come in and do a 3D verification. Also, you can see one side's a 3-axis wall. The other side is a 5-axis swarf wall. So you can see where there's one path down at the main level on the 3-axis wall, and then on the 5-axis wall, we come back in and clean some of those scallop heights out that would be because the wall's tilted out. I'll open up another part, kind of show you some other things. This is more of a contoured part. So you can see we're coming in, we're scalloping as well. So we'll kind of verify this so you can see some of the motion. One thing we do, I don't know if it's going to show it here, but if we do channeling, and then we come back from another direction, like it just did previously. As we exit, we also change how we approach the material. We try not to leave peaks, and if there's a peak, we'll come back out from the other side and roll into it and roll around it instead of just coming straight at it and trying to contact it with the fluid of the tool. So you can kind of see it does the main level, and then we're going to come back as soon as this finishes. We're going to pick up any of those scallop heights. I kind of wanted to show you guys this as well. It's a much larger part. I think the part's about 180 inches or 110 inches long by about 40 inches wide, so there's a lot of motion in there. There is an increased time for generation because of the size and the amount of motion, but we try to handle it as efficiently as possible to keep generation times down as well. So if you see, what we do initially is we layer the part, determine each level, and then once we've done that, you'll see the CPUs will go. We'll utilize as much of the CPU as possible. Once we know the levels, we take each level and send it out to a separate core.
You talked about too the ability to kind of differentiate. You have some choices. You can really have iMachining pay attention to tool life or cutting speed.
With level settings and stuff?
Exactly.
Sure.
I don't know, it seems like it's maybe a go-to medium.
It's a really large part, so there's a lot of calculation going on, and I can cancel it. Any questions? So we'll cancel.
Yeah, I got a question. I know, you mentioned, you talked about how that 70% number was calculated between time periods. Can you give us maybe some case studies or that?
We do have some.
Or maybe some averages that you typically see. Obviously, that's a pretty big one.
Yeah, I mean, it's subjective, as any number is. It's based off of traditional type tool paths, full slots, taking smaller depth of cuts, and using a traditional style tool path. It is really what that 70% is geared towards. It could be less than that. It could be more than that. It depends on the specific application, and that's just kind of our rule of thumb of what we see on an average from our users that are using the traditional constant step over tool path.
It's kind of interesting too, because Greg and I had a part of one of the videos was a ink canal pocket that I believe a gentleman in Colorado was cutting, and he was getting one pocket per tool, and it was taking him about 2.5 hours. And investigated the technology, and wasn't my customer, so I'm not sure the specific numbers, but I know we were cutting that same pocket in about 20 to 25 minutes for him. And we cut 5 pockets. He had a bar of material. We cut 5 pockets, and the application engineer said he could probably gotten 1 or 2 more pockets out of that same tool. So,
And Steve touched base on how do you try to determine, how do you set it up to where gear itself towards more tool life versus cycle time. And most of that is handled with the cutting condition stuff. So if you wanted to increase tool life, you would obviously just lower the level, which is going to reduce your step over, your angle of engagement. Some other things you can try to do is you can go to a higher level, keep your RPMs and chip loads higher, and then lock in your maximum cutting angle to a lower level. So you can change it from 70 to a 50-degree cutting angle. And your min, you can knock it down to a 10-degree. So just keeping your engagement time down, but increasing productivity still.
That does come up. Usually what we tell people is, hey, let's get together with you on one of your parts and tell us the parameters of the machine and whatnot, and let's put it to the test. 70 is kind of the number we homed in on. Seeing a lot more, seeing 10 to 25% more. We haven't had, some customers be really mad that they're even getting 25 to 30% more productivity over their old way of doing things. They can pay for the software.
Yeah. And being an NX user, I understood the pains coming on of trying to do these types of tool paths. So I would create my own geometry. I would create a flattened spiral and then create my step overs and try to mimic things like this. And it took a lot of time because there's no way internally in NX to currently do these types of tool paths. I tried to do the traditional tricoidal that's available in cavity mill and had a lot of broken tools because there was times where it would re-engage in material and make a full slot when it shouldn't have been. Because there is no calculation of where have I been, what am I doing. And as we're taking cuts, each time we do a linearization of a cut, we're doing a calculation and doing a cross-section of the material at that point to determine how much we're engaged. And then we'll either move that point out or in based on our parameters of min and max angle.
I'm just kidding.
You got anything that you'd like for me to show? Or?
Do you have like a cavity mill generated anywhere?
Yeah, we can do a comparison.
Yeah.
So let's go back.
So I guess, kind of what we have currently is a cavity mill, and you don't even have to do triploidal if you don't like. You just do a regular cavity mill operation, and then compare it to iMachining. And we were in class the other day and just did a simple part, and we tried to guess at what we would use as far as speeds and feeds on the cavity mill operation. And we put them fairly close to what the iMachining operation was doing, but we knew that tool was going to engage in the corners, and you can even see it in the verify. That tool is going to engage in the corners, and it's not going to last. It's not going to. It's either going to wear or break, one of the two with cavity mills. So what we end up doing is slowing things down, taking smaller step downs, and then so instead of that, this basically does it all for you. The other thing I really like about this, and again, this is new to NX, so it is new to us as well. So I've just now started kind of testing the software, and the technology wizard. That's the correct term, right?
Yep.
The technology wizard. So that gives you a good starting point. I'm not real familiar with like a lot of the harder materials, so that gives you a very good starting point. And then go test it, and then adjust from there. So that is one of the things that I really liked about it. I was able to just install the software and start creating tool paths pretty easily.
So we had the material based as an aluminum part. I'm going to keep the RPMs the same, and I'm going to do a feet per tooth of 10,000s to give it a little bit of an advantage. So we're going to do 130 inches a minute. But we're going to do a 1/4 inch depth of cut because we're not maintaining a constant step over.
So is it driving, you try and maintain a constant cubic inch? Is that what's driving it, or is it trying to maintain
It's
an engagement?
an engagement. Yes. So we're going to do a 30% step over. We'll be a little generous to it. We'll turn on smoothing and, give it a big enough radius so it's not going to slam the corners too bad. So let's see here. Apples to apples, 34 minutes to 13 minutes. And that's on an aluminum job, which is a pretty big savings as far as motion is concerned.
And you feel like the harder materials, that's where
we really start to shine.
Yeah, the harder the material, that better.
Yep.
Yep.
And the other thing to notice, this is NX time, and you guys know as well, as soon as that program gets to the floor, that 34-minute path takes 45 minutes to an hour to run. So the savings is exponential. Any other suggestions?
I don't think so, unless anybody else has anything else.
I mean, well, let's try and be a little bit more friendly to NX. We won't let it come up. We'll go zigzag and climb conventional with it.
Maybe it's a coil or something.
Zigzag. So a little bit less of the engagement stuff.
Moving forward, like, you guys are interested, is there a scenario where you can do a trial? I mean, I can get you a quote, okay, but I mean, how typically do you think you now?
Really, whatever makes the most sense.
Or
I'd certainly like to do a private one-on-one overview where we can show you in a little bit more depth how the software operates. We like to do the workflow of the software on basic parts. Then we would love nothing more like sending get part from the customer and do an overview or kind of show you how we'd approach your part with iMachining. Yeah, by all means, we'd like to see it in use at your shop. We could provide trials or eval versions. Not a problem.
We definitely prefer doing a little bit of a hands-on approach. That way, when we let you loose with it to do what you want to do, you at least feel comfortable enough that.
Is it where they would send in a sample part, and then you guys would run the tool path on it, and then send that back, and then they would send
Yeah, we would send it back to them, and then we'd also set up a meeting and kind of go through some of the operations, make sure if there's any questions they have that they could be answered on a one-on-one basis.
And along those lines too, licensing. So it is a floating license. So it's however many users. So it's set up as a floating license. So as many users
and
as
it's
you
$7,000
do.
license.
And by floating, it's not a, I've opened NX, so I grabbed a seat. It's, I opened iMachining, I grab a license, I close it, it sends it back. There's no checking in, there's no checking out.
Yep.
It's strictly driven by opening up an iMachining, or if you're external and you generate, or you're doing anything with that operation.
Once the operation is closed, it's checked back in. You don't have to close NX, you don't have to do anything else. So that's something to definitely point out that it is a big advantage, which, that's actually how all the rest of the NX operations are working as well. But, some other solutions aren't, or maybe not like that. So
definitely an advantage to be able to however many units we have. Again, operations closed and somebody else can use it. So.
Craig, there was a question back here too. There is one other, maybe column named competitor. We don't think they are, but could you just maybe discuss a little bit of the differences between iMachining and the other?
Sure. Most of our competitors do not give you any ability to calculate speeds, steps, or cuts. They don't. It's all manual entry. You've got to figure it out on your own. And that's where we think one of our largest competitive edges is we try to help you get there. At least have your best success at first time right. The other thing is our spiral morphing. It is the most efficient way to remove material. Nobody else can do it. They try to, so they'll enter into a pocket, they'll spiral out, and then once they spiral out and hit a wall, then they do D-shaped contouring the rest of the part. We don't. We will do other things like channeling to clear out an area, and then we'll find a large enough area that we can do spiral morphing in, and we'll go in and attack that area. Much more efficient. They're not. They may do localized repositioning, but they're not doing repositioning on a whole part basis. And that stuff is adjustable as well. If you wanted to open that up to where the tool never came out of the part, unless it was going to run into a wall, you could set it to be the whole part. The tool stays down and repositions along a path. So there's a lot of flexibility there. They are not maintaining a minimum or maximum arc of engagement. They maintain a single step over, and that's the only adjustability that they have, which is also, we can get into tighter areas with being able to do that.
And I'll even try, that whole future comparison thing gets tough. I'm going to circle back on what we started with the organization. It was fun for us at iMachining for NX to hear from Chad, because he's a machinist at heart, and the support you get, I think, from the organization dealing with allies and iMachining for NX, I think would differentiate us as well, not to mention just the fixing the place of the software.
And I'm not the only support team on the iMachining for NX side. I've been an NX user for roughly about 16 plus years. Everybody else on the team that's on the support side of it are all previous machinists, users of some sort. They're not your typical support people.
Yeah, so CNC, does you all fit from like your default settings? Is that something you all calculate yourself, or is that straight from like a machining handbook?
It's an algorithm. So we look at a lot of things when we calculate what our spindle speed is, and what our spindle speed is also adjusted. So for example, spindle speed, we look at what your maximum arc of engagement is. And if you're doing a large step over, we'll reduce RPMs to keep surface footages down. If you decrease your arc of engagement, we'll increase the surface footage. Feed rates. Feed rates are constantly changing in iMachining. So when you go from one area to another area, you might slow down to get into a corner because you're engaging a little bit more, and then there might be an area where you're towards the minimum arc of engagement section, and we're going to increase the feed rates to maintain that constant chip thickness. So that's another thing that we do. And then we give the user ability also affects that, what level you're set on, how you feel your setup is. So that all of it together plays into that calculation. Does that kind of answer what you were getting at?